Hello, this is Britt Caswell with another example video. In this video, I'm covering example 3 from section 3-5 in the SavvasRealize Algebra 2 textbook. So we are looking at how to find real and complex zeros. So the first thing I'm going to tell you is when I look at a polynomial, I look at the degree. So because I have a degree 3 polynomial here, that means I'm going to have 3 zeros that I'm looking for. Alright, so I'm going to just right across the top of my screen say those are what I want, is those 3 zeros. Now, one of the zeros is actually going to be really easy for me to see. It's just where the graph crosses on the x-axis. So one of my zeros is here at 2. So what I can do is I could take that 0 and I could divide it out of the polynomial that I have. And so that's what I'm going to do. So I'm going to have 1, 1, -3, -6. So I'm using synthetic division. And I'm going to use my little braid technique here, right? So I drop down 1. 2 times 1 is 2. And then I add down. 2 times 3 is 6. And then I add down. And again, 2 times 3 is 6. And when I add down, I get a remainder of 0. So check yourself and make sure that you have a remainder of 0, or else you messed up somewhere. So what that does is that turns this polynomial into f of x equals x minus 2, right, because the sign changes to write it as a factor, times x squared plus 3x plus 3. So we have factored out part of this polynomial. Now, notice the polynomial doesn't actually cross the x-axis anywhere else. So what we need to do is we need to find out what zeros would happen here with the x squared plus 3x plus 3. And I'll tell you now that because it doesn't cross on the x-axis, these are going to be imaginary or complex. Alright, so to do this, I could either use the quadratic formula, I could complete the square, it doesn't really matter. However you want to go about solving a quadratic. Just understand that that bad boy is indeed going to be complex. So I'm going to use the quadratic formula. So I set up my my little table for me to use it. So my b value is 3, which goes in these first 2 blanks. My a value is 1, which goes in those 2 blanks, and my c value is 3. So as I go about this, I have a -3, and 2 times 1 is 2, and I have a plus or a minus. And when I solve these, I tend to take this radical down to the side and deal with it, because I find that it's a little easier. So 3 squared is 9, and then 4 times 1 times 3 is 12. So this is the square root of -3, because I just subtract those. Now 3 is prime, so I can't actually take the square root there, but I can take the negative out in the form of I. So this will turn into I root 3. And so that's how we're finding our other 2 zeros. So the first one is where this is a plus sign instead of plus or minus. And the second one is where it has the minus. So there we have it. These are my 3 zeros. And remember, these imaginary zeros, they always come in pairs. I'm going to put that here. And they come in pairs of conjugates. So remember, a conjugate is just when it looks the same, but the sign between them is missing, or sorry, is opposite, because there's no i's in our polynomial. So there's no I in the polynomial, so they have to cancel out. So that's just to help you remember that for later. Alright, so I didn't give myself very much room on this, so I'm going to try to squeeze these together as much as I can. Here's a line to remind myself I need to give myself space. So to start, this is x to the third, so I know I'm going to need 3 zeros. Okay, now one of them appears here at 3. And so I'm going to use my synthetic division to divide the 3 out of this polynomial. So I have 2, -8, 9, and -9. And I use my braiding technique, right? So 3 times 2 is 6. 3 times -2 is -6. 3 times 3 is 9, and you need that remainder of 0. So this polynomial now turns into f of x equals x minus 3, again because you have to flip the sign from that one, times 2x squared minus 2x plus 3. And so then we need to go about, I'll use blue on this one, then we need to go about actually solving this part of the polynomial. So I'm going to again use the quadratic formula. That line did me no good, did it? So all over 2 times a. So my a value is 2, so I'm going to fill those in here and here. My b value is -2, and my c value is 3. So this turns into -2 is a positive 2, and here 2 times 2 is 4. And if I deal with this here on the side, I get the square root of 4 minus, that makes 24. So I'm dealing with the square root of -20. Now if I do the prime factorization of 20, I get 2 times 2 times 5. So the negative comes out as an I, the pair of 2's comes out as a 2, and the 5 stays inside. In my last step, I have a 2, a 2, and a 4, so I can actually divide out the greatest common factor between those. So I'm dividing each of these by 2. So my remaining zeros, I have 1 plus I root 5 over 2, and I have 1 minus I root 5 over 2. So there are my 3 zeros on that one, which I should probably like box or something. There we go. Now on this one, I have a total of 4 zeros, okay, because my degree is 4. So I'm going to say x equals 4 times. Now this one's nice because 2 of these zeros I could see. They're already where the graph is crossing the x-axis at -2 and +2. And so what I'm going to do is I'm actually going to use synthetic division twice in order to simplify these. So first I'm going to do it with the -2. Alright? And remember, I'm missing a cubic term and a linear term. So when I go to write out this synthetic division, I need to make sure to include zeros where the cubic and the linear go, like that. So I drop down my 1. -2 times 1 is -2, and then I add down. -2 times -2 is +4. -2 times 1 is -2. -2 times -2 is 4, and I get a remainder of 0. Alright? So this right now has the polynomial looking like f of x is equal to x plus 2, because you have to flip the sign on this, times x cubed minus 2x squared plus x minus 2. And I'm sorry, I know I'm super squished there. Let me see if I can zoom in and make it easier to see. So now that I've done it for this one, now I'm going to use synthetic division again on this 0. Okay, so I'm going to put the 2 outside the division house. And instead of dividing the original function, I'm going to divide just this part of it. Alright, so I'm going to use the 1, negative 2, 1, negative 2. So I drop down my 1. 2 times 1 is 2, and then I add down. 2 times 0 is 0, and I add down. 2 times 1 is 2, and I add down and get a remainder of 0. So now my polynomial looks like f of x equals, I have my x plus 2 from the blue, I have my x minus 2 from the green, and then I have x squared plus 1 from what's left over on the green. So to get my last two zeros, I'm going to take this x squared minus 1 plus 1 and set it equal to 0. Alright, now I could use the quadratic formula, I could use completing the square, or because I don't have a linear term, I could just set it equal to 0 and solve for it directly. And so that's what I'm doing here. So I subtract the 1 from both sides, and then to get rid of the square, you have to take a square root. And don't forget to put the plus or minus in front of your square root, or you're only going to get one answer. Now the square root of negative 1, that's the definition of I. So my last two zeros here are positive I and negative I. And notice those are conjugates, so they cancel each other out when we have our polynomial. So there we have it. That is one way of finding some of the real and complex roots in a polynomial. Until next time.